lengths of any two sides of a triangle is longer than the third. So that looks like something like this. If it's longer, it's going to be bigger than, so this is the first side and the second side, and this would be the third side. Okay. Equal to the sum of the remote interior angles. Okay, well that sounds like our exterior angle is equal to the interior plus the interior, the ones that are across the triangle. A triangle with exactly two equal sides. So that looks like that. And every side of a triangle is a different length. So regardless of what it looks like, that side is different from that side, and those are different from that side. Okay, so then when I come over here, isosceles triangle. Well, I know that that has two equal sides, so that's what that looks like. Exterior angle, that's that one that's equal to the sum of the remote interior. Scalene, all the sides are different. Triangle inequality theorem. This is the only thing I have going on over here, which is an inequality. So that is B. And then an equilateral triangle is a triangle with three equal sides. Okay. There we go. So that is all the vocab. Okay, in this section, we're going to be dealing with interior and exterior angles. So the interior is inside, the exterior is outside. All right, so I have three angles. I have one here, I have another here, it's a different number, and I have this one over here. Not sure if it's a different number, but it looks like it. So I just have to subtract both of those from 180. So I'm going to write down 180 minus 85 minus 42. And I just have to figure out what that is using my calculator. 42 and 85. All right, so I get 53 degrees. That's here. And another thing is that all of these angles are acute and all of my numbers are acute, so that does make sense. To find the unknown exterior angle. Okay, exterior equals interior plus interior. Those are these remote ones over here. Okay, so this question mark, I don't know what it is, but I do know I have an interior one of 38 and an interior one of 80. All I have to do is add them together. 80 plus 38, I get 118. All right, 118 degrees. Okay, there are some people that are finding this angle right here. And then they're finding this angle, and that is not wrong, but it is more work. Okay, so it is definitely more work. The other issue with doing it that way is that in a question like this, I don't have enough information to do that. So it's really important that you rely on the exterior angle theorem, okay? That you make sure that you're adding those two and then making them equal that exterior angle. Okay, so over here, we have to find the QSR. So we're looking for this angle over here. And in order to do that, we have to find X. So this is what I was just mentioning, the outside angle right here equals these two angles right here. I'm going to add them together. So 6x is the exterior. And then I have two x's. And then I have a 3. And then I have the 77. You can also combine them visually over on the triangle like I've showed you in class. So that would be 80. Okay, so you could skip that step and go straight there. Then I'm going to subtract my 2x from both sides. And I get 4x is equal to 80. I divide by 4. So x is 20. Now that I know that x is 20, I'm going to come over here to 2x plus 3. And instead of x, I'm going to write a 20 and then plus 3. So this is going to be 43 degrees. Okay. So again, we want to add the remote interior together, and it equals this exterior angle. Okay, we're going to do that one more time. All right, I'm going to circle these. I know I have to add them. They have to equal my exterior angle. So what I was saying a minute ago, if you're wanting to just combine visually, 7 plus 63, well, that is 70. So 3x plus 70. And then that would equal my outside angle of 5x plus 50. And now I'm going to solve that. 3 is smaller, so I will subtract 3x from both x's, like that. That is gone. I'm going to need to take the 50 to the other side. If I bring my x to the right, I have to take my constant to the left. So I'm going to move my 50 over here using subtraction. 0 pair, 0 pair, everything is good. 70 take away 50 is 20. 5 take away 3, that leaves me with a 2x. Divide by 2 and I get 10. Okay, so that's here. Regardless of what equation you choose to use, make sure that you write it where we can see it front and center. Okay, some of you, though, we get kind of lost in your work, okay? And we really need to see where things are. Now we need to find QPN. So we got to find this exterior angle. We want to know what it is. Well, instead of x, I'm going to put a 10. So 5 times 10 plus 50. That's 50 plus 50, which is 100. This is an obtuse number, and that is an obtuse angle. So that tracks. Okay, moving on. Okay, now we are to isosceles and equilateral triangle. If it were me, I would draw an isosceles triangle up here just so that I know what it's supposed to look like. I would also draw an equilateral triangle so that I know what that looks like. Okay, so this says to find x. I'm finding the side length. Okay, this entire side is 112, and that tick mark says it's congruent to that side. So this side is also 112 meters. This one, this is the base. It is nothing more than a distractor. Solve for the missing variables. Okay, so we're going to solve this one and this one for the variables that we see. So a couple of things I notice about this one here. 4 and 4 are the same. So this is isosceles. which means that angle and that angle, those base angles are congruent. So I know automatically that that is 71 degrees. Okay, so that's good. And then the only thing that I have to find is y. So I have a 71 and a 71. So 180 minus 71 again. 180 minus the two 71s. And I get 38. Okay? And all of these angles are acute, so that makes sense that all of the numbers are acute. Okay, then I'm going to go like this because I like looking at my isosceles triangles where their vertex angle is pointed up like a party hat. So if this is isosceles, then that means that that angle and that angle are the same. So here is 2x over here, here's 2x over here. This is 40, and it does not equal either of these. But what I do know is that the 2x and the 2x and the 40 add to 180. They're all inside. So I have the 40 degrees, and then I have a 2x here and a 2x here, so that is 4x, and all three of them have to add to 180. So once I do that, I can subtract my 40. I get 4x is equal to 140. And when I divide by 4, I get x is 35. Okay? X is 35. Now that is not a degree, that's just a variable. Over here, the x and the y are degrees. Okay? So a little bit different there. Okay, next we have find the value of x. And we have two diagrams. Okay, in this picture here, I see two base angles that are the same measure. That means that it is isosceles and my two sides are equal. So I'm going to make an equation. 2x plus 6 equals 3x minus 6. Now, whatever you do, please don't say that the 6's cancel, because they don't. They're on opposite sides. I'm going to subtract my 2x, and then I'm going to add this 6 over to the left side. So that's a 0 pair. That's a 0 pair. You actually get 12 is equal to x. Okay? So don't look at this, and this is a very common mistake, to look at those two and say that they cancel out, and then try and tell me that 2x is equal to 3x, and then you're not sure what to do. So be careful with that one. In this particular diagram, I can see that it is equilateral. I can see that the x represents all of the angles. And I know for a fact that all angles of an equilateral equiangular triangle are 60. And I don't even have to do anything to get it. But if you forget, you have 180 degrees for angles 1 and 2 and 3. They're all the same measure. So if you divide by 3, you do indeed get your 60. Okay, so this one here is an interesting question, and this one looks very similar to your test. And what you need to know is we have a 124 right here. Okay, this side and this side are equal. So that means that this x value over here and that x, this would be another x value over here. Those would be the same number. So to get this one, 180 minus 124, because those are a linear pair, and that would give me 56 in that corner. It would also give me 56 in that corner. Well, if both corners are 56, then that means that this side over here is also going to be 124. Okay, so they're the same. It's like a mirror. It's almost like there's a little mirror going down here, like that. Okay, and then, so I know that x is 56. I know that z is 124. Okay, so I just got to find y. And the easy thing is that x and y are inside. Okay, so there's actually two ways you can solve this question. You can do 180 minus 56 minus 56. And that'll give you your y value up here. Okay? You also could recognize that if this outside angle is 124, then 124 on the outside is equal to these two right here. Or you could go this way. So 56 plus y. So no matter what you do, okay, if you do 180 minus 56 minus 56, you will get 68 degrees. If you do 124, okay, and you take away 56, you still get 68 degrees. Either way you work it. So there are multiple ways to solve some of these. I encourage you to use the easiest way. Okay, triangle inequalities. All right, so for triangle inequalities, we can take the two small numbers and add them together, and if they are bigger, if their sum is bigger than the largest side, it's a triangle. So I always like to circle my two smallest numbers. That way I know which ones need to be added, and then I'm going to compare them to the other number. Okay, so in this one here, I have 2 plus 9 is greater than 12. Well, 11 is not greater than 12. So that is no. That is not a triangle. And then the next one, I have 10 plus 7. That's 17, greater than 15. And that is true, so that is a yes. All right, so right here, I just want the range of possible values of x. Okay, so we're talking about the smallest number, and then x, and then the largest number. In between these two numbers is the third side of our triangle. Okay, so the way you do that is you're going to add the numbers together, and you're going to subtract the numbers from each other. You just take the two numbers and you just add them and subtract them. 24 plus 9 is 33. So that's my largest number right? This has to be small, this has to be large. 24 minus 9 is 15, so that would be here in my small spot. So the third side is bigger than 15 and smaller than 33. For number 18, I still want to add and I want to subtract the two numbers from each other. So 19 plus 5 is 24, and 19 minus 5 is 14. Okay? And so I know that 14 is my smallest, 24 is my largest, so my third side is somewhere between those two numbers. And then we get to ordering. Okay, so we're going to order our angles from least to greatest. So that means this is the smallest, the middle, and the large. So small, medium, and large, just like French fries and milkshakes. All right, well, the smallest side is across from the smallest angle. So this is small. So my angle across from that is the smallest. So that's 5. I'm sorry, C. I wrote the side length. I did exactly what I warned you happens when we don't pay attention. So this would be angle C. Then we have the middle number, 9, and that is across from angle A. And then we have 15. That's my largest number, and it is across from angle B. All right, and we are going to do the same thing on this one. I can see that this is my smallest, my middle, my medium, and then this is my large. Okay, so if 5.2 is my smallest, it is across from angle J, which is my smallest. The medium size, 6.8, that is across from angle L, that's my medium size. And 8.9 is my largest, and it is across from K, so that is my largest. And then we're going to order our sides. We're going to do the sides in order from least to greatest. So small and medium and large. Small, medium, and large. And then on your test, just so you know, you'll have some blanks like this. And then we're going to go ahead and put this segment notation right here. We're going to already have that for you. All you have to do is put the letters. Okay? That's all you have to do is put the letters. So I'm going to find my small and my medium and my large. Well, the smallest angle is across from the smallest side. So this is CB, and it goes under that little segment notation. 59 is my medium angle. It is across from CA. And then 71 is my largest angle, and it is across from AB. Okay, we have all those accounted for. And then finally, this one here. Okay, so we have small, and that angle is across from CA. So you also can do one at a time. We have the medium angle, and it is across from AB. And then we have 90, which is our largest angle, and it is across from CB. Okay, so there's those. And these, in the past, students know exactly what to do, but they don't read carefully, so they do it backwards. And they give me angles when they should give me sides, and sides when they should give me angles. Okay, and now we have a puzzle on the back. All right, let's go ahead and look at this puzzle. And I think we've done one similar to this in our notes. It says that QN is going to bisect angle PQR. So this angle here is cut in half. It's 30 on that side and 30 on that side. And that means that N is my midpoint. Okay. So this side here and this side here. So if that is 7, then this is 7. Then we got to classify the triangles by their angles and sides. Okay, before I do that, I notice here's 14 and there's a tick mark, so that part is 14. All of this is 19. And if I look at 14 here and 5 there, I get 19. I have 3 angles, and I don't need to know this side right here. I have a 60 here, a 60 here, and here 30 and 30 make 60. This one here, that angle along with my 60 is a linear pair, so that is 120. That's my 7. It's really small. So this entire side is 14, and that little part is 5. That part is 18. Okay, so PQR. This triangle, PQR. Well, I notice that all of the angles are 60 and all of the sides are 14. So that would be, well, they are all acute, but we want to say that it is equiangular, equilateral. Okay, then we have PRT. Now PRT is this triangle right here. I have an obtuse angle. I've got some acute angles. And I have 14 along this side, 5 here, and 18 here. So that is an obtuse scalene. And then we have TQS. That's this big triangle over here. TQS. Well, first of all, I notice all of my angles are acute. So I know I can write that down. And then I see this side is 19, and so is this side, because I have a 14 here and a 5 here. 14 and 5 is 19. So it is an acute isosceles. And then finally, we have QNP. That's this angle or triangle right here. Okay, so it is a right triangle, but it's also scalene because this is 7 and that is 14. And this side right here, I would need the Pythagorean theorem to get. So this is a right scalene. And there we go. That is the end of our test review for Unit 3. Okay. And this key will be hanging out in Schoology.